Let's start with the first example from the workbook, the unit on two dependent sample tests. So what we have here is we have some data from a study in which rats received either a saline or a drug injection. The first step that I need to do is calculate the differences between pairs of scores. So I made a new column D here. I put in a formula, the one cell minus the other, and then I've copied this down. I need to calculate the mean of the differences, the standard deviation of the differences. I need to calculate the number of pairs of scores, or the degrees of freedom, or both. I'll do number of pairs of scores and then calculate degrees of freedom from there. I need the standard error of the differences, the t, and then the p. If you want to know what these terms are, just take a look in your workbook. They're all pretty straightforward terms. To calculate the average, or the mean difference, I'm going to use the function average. To calculate the standard deviation of the differences, I'm going to use the stand_div function. Now, a quick note here, and that is I have an earlier version of Excel here, and what that means is I'm going to use stand_div, not stand_div_s, because that's not available, but as you can see, this is the standard deviation of the sample. The number of pairs of scores, I'm going to use the count function. It's counting the number of scores I have. Counting the differences at least. Our degrees of freedom in this test is the number of pairs of scores minus 1. The standard deviation of the differences is the standard deviation. The standard error of the differences is the standard deviation divided by the square root of the number of pairs of scores. Just enter that formula. Our t then is the mean difference divided by the standard error of the differences. That's our p-value, 4.479. To determine the probability, I'm going to use t_dist. Enter that, enter the degrees of freedom, and this is a two-tailed non-directional test. So I will enter 2 in there. Again, this function is an old function, but it returns the proper p-value. In the newer versions of Excel, you might use tdist.2t. Now, I can do this much easier using the Data Analysis Toolpack. If you'll see, we're given a number of t-test options. And the one to use, though, is to remember that a dependent sample is a paired sample. So here we go. I click OK and select the range, the ranges of the variable values. I'm going to enter 0 for my hypothesized mean difference, and I'm going to place it right here. If I click OK, you can see that the computations are identical. You can see the p-value of the two-tailed test given right there. That's the non-directional test is given. The t-stat is identical, as are the probabilities.